Hello dear students, greetings of the day. I, Mohammad Zishan, welcome you to the online classes of Bloomingbird's Code School Sambal. Dear students, this is the third lecture of our chapter 3 of geography, which is Earth's structure. In this chapter, we are studying about the interior of the Earth. So, dear students, so far we have studied about the sources of information, that how do we come to know about the interior of the Earth. In that series, we have studied about the seismic waves also. We have studied about the volcanoes and about the meteorites, and then we also studied about the composition of Earth. And before that, we studied about the structure of the Earth, in which we studied about the hydrosphere, lithosphere, and atmosphere and biosphere. Then we studied about the interior of the Earth, and in that series, we studied that how Earth is composed of, and we studied about the Sima and Sial and knife. We studied that majorly Earth is composed of these materials: silica plus aluminium, which floats on the upper surface of the Earth, and then sima, which is on the lower portion of the crust, and upper mantle, that is composed of sima, silica and magnesium, and below that there are the heavy metals like oxygen and nickel and iron and magnesium, right? So then we studied that the third layer, the major layer of Earth's composition is of knife, that is composed of nickel and iron. After studying all those things, we are going to study about the three major layers of the Earth. Dear students, we have divided the Earth into the interior of the Earth into three parts. The outermost part of the Earth is called crust, and the innermost part of the Earth is called core, and the part which is between the crust and the core is called mantle. Not that one mantle, M-A-N-T-L-E, mantle. Okay. Then when we study the crust, so the surface of the Earth on which we are standing, that surface is crust, right? It is composed of hard rocks, right? It gives us a platform to stand. The upper part, the outermost part of the crust is having soil also, which is very fertile, and which is responsible, which is one of the you can say factor responsible for the existence of life on Earth, right? All plants grows there. Clear? Then this starting from there very upside till 30-kilometer downside, okay, or 50-kilometer downside, or maximum 60-kilometer downside, right? That layer of Earth is called what? Crust. Now, when you are on a continental crust, on a mountain, and then downside you are digging, so up to a depth of 60 to 70 kilometer, you will find that particular layer which is called as crust. Okay. Now, if you start digging from the oceanic surface, sea floor, right, then the width of this crust may be of from 8 to 10 or 12 kilometer, right? So that is very thin, you can say. So if you want to understand the structure of Earth, just imagine that you are having an apple, right, and the peel of apple is like crust. Peel of apple is very thin, right, and that can be considered as crust. Then the pulp, right, may be called the mantle, and inside the area where we are having seeds and all that thing, that is called core. Core is the widest part of the Earth. So here I can draw, I can show you like this. This is Earth. This innermost part is core, and this outermost part, middle one part is mantle. This is core, C-O-R-E, core. This is M-A-N-T-L-E, mantle, and this is C-R-U-S-T, crust. Here I have shown properly. This much portion is crust, and from here to here we are having mantle, and from here to here we are having core. So, dear students, we are going to study these three layers of earth in detail, and we will also study about the area where the properties of one layer changed and the property of another layer starts. That particular area or that particular thin layer is called the layer of discontinuity, that has been given by various geologists or scientists, and over their name only it has been named like Gutenberg discontinuity, Morovich discontinuity, Lehman discontinuity, Rapid discontinuity. That also we will study. Okay, so let us begin this with crust. So as we know that we are comparing the interior of the earth as an apple, so the outermost part of the apple, which is peel, is very thin. Okay, so like that only the outermost solid layer of earth is called crust. Now this crust can be divided into two parts, upper crust and lower crust, right? And this crust is also called lithosphere. Its thickness is around 60 kilometer, and it can be called continental crust also and oceanic crust also, right? Continental crust means the crust of the earth which is on the dry land, like we are here. Okay, that starting from this region to the starting of the mantle, okay, that can be called what, continental crust. And oceanic crust is the crust which starts from the sea floor, okay, seabeds. Okay, so and then its density, the density of crust increases with increase in depth. As you will keep going downside, the density of crust will keep increasing, right? And the average density of earth's crust is 3 gram per centimeter cube, which keeps on increasing as we go downside. The crust is composed of silica plus aluminium and magnesium. Upper layer of crust is composed of silica and aluminium, and the lower crust is composed of silica and magnesium. The silica and magnesium extends till the upper mantle also, right? Now here we are having crust. We have categorized crust into two parts, upper crust and lower crust. Okay, so the area or the region where the properties of upper crust get changed with the lower crust, that area or that layer is called Conard or Conorod discontinuity. Okay, here what is happening? Here the uh, continuity of properties is ceasing. Okay, these are discontinuing. Okay, the properties are changing from here to here, right? So the region where properties are changing, that is called discontinuity layer, right? So it was discovered by Conard or Conrod. Okay, so it is called Conrod or Conard discontinuity between the upper crust and the lower crust. Now we have studied that crust is the solid part, and we have also studied that it extends to 60 kilometer, right? Then after that the upper mantle starts. Upper mantle starts, and the discontinuity between the lower crust and upper mantle is called Moravec discontinuity. So you can say that the what is the name of the discontinuity between crust and mantle? That is Morovich. It is called Morovich or Moho discontinuity, right? Then just below upper mantle, okay, after you can say 100 kilometer to 400 kilometer, when you go from top of the earth to 100 kilometer downside or till up to 400 kilometer downside, you will find what, an area where the rocks are in molten form but still behaves like solid, and that area is called asthenosphere, right? So asthenosphere is in mantle. Okay, it is the part of mantle and it is below 100 kilometer to 400 kilometer, right? That is what? That is mantle, right? This is mantle. This entire region is from here to here. This entire region is mantle. This is upper mantle. This is lower mantle. In upper mantle, we are having asthenosphere also. This entire is upper mantle, okay? And here in between, when we go 100 kilometer down from the top, which layer is there? Asthenosphere. Asthenosphere. These are the rocks. These are the rocks in molten form, okay? And the entire upper mantle as well as crust keep floating on asthenosphere, okay? These keep floating on asthenosphere, but still asthenosphere behaves like solid, and that is the reason that secondary waves are able to pass through this, okay? Even these are in the molten states, secondary waves pass through it, okay, until the core. Getting or not? Whereas at the core, at the upper core, which behaves like liquid, okay, they are not able to pass. Clear? So what we have studied? We have studied about the asthenosphere, where asthenosphere is found below 100 to 400 kilometer below the surface of the earth, right? What is asthenosphere? These are the molten rocks or rocks in the molten form, right? Getting or not? So here we have come, where here we have reached in mantle. Mantle is the thick layer, right, of earth, and it is around 2900 kilometers, starting from 700 kilometer here till 2200 kilometer here, okay? This is of 2900 kilometer thickness, right? From 700 is upper mantle and 2200 kilometer is lower mantle. Clear? Then it is between crust and core. Yes, this is the crust and this is the core, right? So it is between crust and core, crust and core. Clear? And then the discontinuity between the crust and the mantle is Morovich discontinuity. I have already told you. Then what it is composed of? As I told you that the upper mantle is composed of silicon and magnesium, as well as oxygen also. So this is composed of silicon, magnesium and oxygen, right? Then what is the density? Density starts from 3.5 gram per centimeter cube to 5.5 gram per centimeter cube. That is the average density, and density keep increasing as we go downside, okay? Average density of mantle is 3.5 gram per centimeter cube to 5.5 gram per centimeter cube. Then after that, we are having what is the temperature of mantle. So mantle temperature goes from 900 degrees Celsius to 3700 degrees Celsius. 9900 degrees Celsius to 3700 degrees Celsius. And then presence of solid or molten rocks. Okay, this is what? This is the asthenosphere we are talking about. So in upper mantle we are having asthenosphere, where the rocks are in molten form but still they behave as solid, okay? If the temperature is 1400 degrees Celsius, that much temperature is sufficient to melt a rock, okay? A rock can be melted on 1400 degrees Celsius, right? So here temperature is 1400 degrees Celsius, and then the rocks are in molten form, but it is having tremendous pressure from the upper crust and upper mantle. Look at this one, mantle and crust is exerting pressure on asthenosphere. Because of that high pressure, it behaves like a solid. Okay, it behaves like a solid, but still it is in which form? It is in the form of molten rocks. Okay, and then after that we will study. Okay, then we have studied that okay, this is 700 kilometer wide and this is 2200 kilometer wide, lower mantle. The discontinuity, right? The discontinuity, this is more dense and this is less dense, okay? So here the properties are getting changed, and this layer where the properties of mantle are getting changed is called Raphty discontinuity. Which discontinuity? Raphty discontinuity. This is 700, this is 2200, and from here to here it is 2900 kilometer. This is 2200, this is 1200, okay, and from here to here it is 6378 kilometer entire, okay, 6378 kilometer. Clear? Now, what I was saying, huh? Now we will study about the core. So core is called barysphere. Acha, on the basis of this barysphere, mesosphere, we can divide Earth again into three parts. Okay, lithosphere, mesosphere, and barysphere. To mantle we call mesosphere, and to core we call barysphere, and to crust we call lithosphere. So crust is also known as lithosphere, and mantle is also known as mesosphere. You will also study mesosphere when we will study about atmosphere. Okay, mesosphere is a layer of atmosphere also, right? But we are not talking about that one mesosphere. Okay, we are studying about the mesosphere which is inside the earth, interior of the earth. So mantle is also called mesosphere as it is between the two layers. Meso means something which is between, right? Mesosphere, and this is the barysphere. Barysphere means the layer which is having heavy metallic rocks. So this barysphere is having nickel and iron. Nickel and iron are the very heavy metals, okay, and iron is called to be the reason of the earth's magnetism, as in the earth's center or the core, at the core of the earth, there is iron abundance, so that may be the reason for the earth's magnetism. Okay, it is said, but it is still being researched. Then second is we are the discontinuity which is between mantle and core is called Gutenberg discontinuity. The layer where the properties of mantle and core is changing, okay, that layer, that region is called Gutenberg discontinuity. Then the layer which is in between the outer core and inner core is called Lehman discontinuity. So Lehman discontinuity is between outer core and inner core. Gutenberg discontinuity is between core and mantle. Raphty discontinuity is between lower mantle and upper mantle. Morovich discontinuity or Moho discontinuity is between mantle and crust, right? And Conrod discontinuity or Conard discontinuity is between lower crust and upper crust. This discontinuity's name you have to remember. Question may be asked between these two layers which discontinuity is there. Then after that we have already studied that at the core we are having which material, which elements are there, nickel and iron. Then what is the density of core? The density of core ranges from 5 gram per centimeter cube to 13 gram per centimeter cube, okay, and it is having tremendous temperature. Temperature is very high. It may range from 4400 degrees Celsius to 6000 degrees Celsius, right? That was all about the interior of the earth. You have to memorize all these things, right? I hope your concept will be clear and all facts are available to you. Just read the chapter and try to understand it. Thank you so much.